Okay, good afternoon, ladies and gentlemen. Buongiorno e benvenuti alla nostra conferenza.
Welcome to our conference.
I was just about to say that. Thank you very much. Welcome to the third edition of the Future of Retreading and Recycling conference at Future Motive Expo and Talks. Thank you very much for coming. I hope you'll find it interesting and rewarding. Thanks also to Future Motive for hosting us today. Before we start, just a few words about what you're going to see today and how this is going to be organised. We're following the format of the previous events that we've had, where we have 6 speakers. Normally we have 3 speakers talking about retreading and 3 talking about tyre recycling. Well, interestingly, there are 4 of the speakers today are really crossover speakers, so what they're talking about will be of interest both to the retreading and the recycling communities, and I think that to a degree illustrates the convergence of retreading and recycling into a subject where we're talking about the role of both retreading and recycling within the circular economy. So we'll have 2 sets of speakers, 3 each. So they will speak for 20 minutes each. So the first 3 speakers are sat on the stage, and if there's time left at the end of the first 3 speakers, I'll put some questions to the floor, and you can ask some questions to the speakers. There may not be time for that though, because we are under a time constraint, because we need to finish today by 5 o'clock, so we can clear the room and change the stage for the Recircle Awards ceremony, which takes place at 5:45. So, and of course you're all invited to come along to that. Just to repeat what I said before, if the first speaker is Stefano Carloni, and he'll be speaking in Italian, so if you don't speak Italian, please download the web app, which is on the door, and then you can have a simultaneous translation in English. Okay, so the other thing before we start, a bit of housekeeping. As far as I'm aware, there's no fire alarm today, so if you hear a fire alarm, it's for real. So please make your way as quickly as you can down the stairs, or alternatively follow me, because I can assure you I'll be the first out the door if that happens. Okay, so to open the conference then, I'd like to welcome to the stage Stefano Carloni, who is the President of the Italian Retreaders Association, AIRP. Stefano.
Buongiorno a tutti, grazie per la vostra presenza oggi e grazie a David Wilson e a Valley Bridge Media Service per aver riportato a Bologna anche quest'anno i loro eventi internazionali dedicati all'industria della ricostruzione e del riciclo dei pneumatici. Ci eravamo salutati qui lo scorso anno in occasione di Automotive 2022. Oggi ci ritroviamo in occasione di un nuovo evento, il Automotive, che è interamente dedicato alla transizione energetica ed ecologica e alle innovazioni del settore automotive. Anche qui nella parte espositiva ritroverete degli importanti rappresentanti dell'industria del pneumatico in tutta la sua filiera, ma non è l'esposizione a cui siamo abituati con Automotive. Qui sono in mostra le innovazioni prima dei prodotti, sono in mostra le possibilità che l'industria e le aziende offrono per la mobilità del futuro. Ecco perché in questo contesto, e forse soprattutto in questo contesto, credo che la ricostruzione dei pneumatici sia di casa. Pur con i suoi oltre 80 anni di storia, rappresenta una tecnologia di assoluta importanza per la sostenibilità della mobilità, così come anche tutta la filiera del riciclo e del recupero di materia prima ormai assume un ruolo imprescindibile per chiudere il cerchio dell'economia circolare. Tuttavia, questi due settori, la ricostruzione ed il riciclo, non potranno rispondere alle sfide della transizione ecologica e della nuova mobilità senza una robusta dose di innovazione tecnologica. In un momento in cui lo sviluppo dell'industria dell'automotive vede un'accelerazione senza precedenti nella storia, tutte le tecnologie coinvolte nella filiera sono chiamate a uno sforzo importante, ma con l'obiettivo di stare al passo con i tempi, cioè non tanto con l'obiettivo di stare al passo con i tempi, ma con l'obiettivo di guidare la corsa alla sostenibilità. Ecco quindi che ci ritroviamo oggi per conoscere e condividere delle importanti innovazioni tecnologiche in questi settori. Alcune di queste innovazioni si trovano forse ancora nello stato embrionale e devono raggiungere una piena applicazione, devono ancora definire al 100% le loro possibilità. Credo che quindi questo sia un momento importante di confronto, di condivisione, di discussione, per dare un contributo significativo alla lunga marcia verso il futuro a cui tutti noi siamo chiamati a partecipare. Pertanto, mentre il ruolo delle aziende è quello di lavorare al meglio per contribuire a sviluppare il rispettivo settore, nel nostro piccolo come associazione e come organizzatori di eventi ci sforziamo di sostenere e di dare la massima visibilità possibile a queste iniziative per mantenere alta l'attenzione verso le buone pratiche e per continuare a confrontarci e a rimanere in contatto. Grazie e buon lavoro.
Okay, thank you very much, Stefano. So, our first speaker today is Michael Schwaemmlein, who is the Technical Director of BIPAVER. And Michael is going to speak about a subject that will be of great interest to all the retreaders in the room, and that is the retreading industry labelling proposal for C3 retreads. So, Michael.
Yeah, ladies and gentlemen, thanks, David, for having the opportunity speaking here. My name is Michael Schwaemmlein. I'm the technically responsible secretary of the European Retreading Association BIPAVER and also the technical director of the German Trade and Retreading and Vulcanizing Association BAV in Bonn. The subject I'm going to speak to you about is labeling for retreaded C3 tires. I mean, many of you might. I also like the wording crossover speaker. I think we are all part of the circular economy scheme on the tire segment. And the first and priority of this recycling scheme is reuse. And reuse, of course, is clearly repair and retreading. And that is why we are trying to get the retreading performances as close and as reliable to the new tire as possible, and that's the background why we started quite some years ago what I call the labeling project. And you know, all the EU projects take some time. So the first presentation we started to the EU Commission was in 2017. Yeah, I'm not mistaken, 2017, 5 years ago. And we still have no finalized solution, but we're still hoping, and the hope dies last. So why are we starting with a labeling approach? Because many of the retreaders may think, why do we need another burden on the retreading segment, which is fairly often SME characterized? And therefore, I need to go one step back, because in the beginning, when we tried to promote retreads in the market, the first excuse of the public, of the politicians and of the users were that retreaders might not be reliable. They might not last, they might fail more often than new tires, and so on. That vanished after, in 2006, we established the type homologation for retreaded tires, the quality assurance system, the COP testing, and so on. And I think by now we can say there are no more doubts on the reliability of retreads. Also, there are many studies in the US and EU existing showing that the failure of retreading tires is actually always in relation to the spread in the market, to the repetition of retreads in the aftermarket. So they fail more often, and most of the failures are not relied to the process or retreading itself, but to the application under low pressure, overcharge, and so on. So now the excuse why they are not promoting retreads is no longer the reliability, but that they can't prove their safety and environmental properties, where the new tires, as we all know, have their minimum requirements defined in the ECE UN R117. That is still not existing for retreaded tires, and therefore there are no labeling requirements for retreads so far. So the first approach was, and that is what we did in the Retire project that was done a few years ago by BIPAVER with EU support, and afterwards a very large study carried out by the colleagues of ETRTO. And I can say today I'm not only speaking on behalf of BIPAVER, but on the whole retreading industry, meaning all the new tire manufacturers which are active in retreading, but also the independent labeling. So our interest was to support a labeling scheme which is assuring that the methods and the processes to achieve that is in line with what the SME structured independent retreaded industry can manage. Saying everybody knows how the labeling for new tires is done. A new tire is produced 1 million times the same way with new materials, and it's tested once and produced 1 million times, so labeling is for one tire type quite easy to do, whereas a mid-sized retreading workshop is easily facing about 6,000 to 7,000 different product combination he's doing, resulting from the amount of dimensions he's producing, of the amount of designs and patterns he's producing, the various materials manufacturers, the different process type, being retread or mold cure, the different tread width he's applying, and so on. So if you multiply all these factors with each other, you easily come up about 6,000 to 7,000 possible solutions. So, first of all, what is labeling about? We want to provide relevant information to end users and to public authorities, which are showing that a quality produced retread is absolutely capable of meeting the same requirements and the same performance as quality new tires. Last but not least, as I said before, retreading is the priority reuse case in the circular economy part of the tire segment, and we managed also from BIPAVER side, including the intent of many other parties, that in the EU Sustainable Product Initiative, also tires are now turning up. And of course, it should lead to positive contribution to the EU CO2 targets while preserving safety, economical and technical feasibility, as I said, because a major part of the independent retreaded are not big industrial retreaders, but very small SMEs. When we set the feasibility assessment up, it was very clear that we are not facing any problems with the properties of wet grip, external noise, but we are facing a lot of problem with rolling resistance because wet grip and rolling noise is basically depending on the tread only and the casing itself. So the used tire we are using to produce a new retread has a very large impact. And as I said, for wet grip, we were pretty sure that we keep in line with the structure of the labeling set up for new tires. There's no change needed compared to the labeling classification as it is already set up for wet grip. So we can basically staying with it because it's primarily depending on the tread and the used compound itself. The same for external noise. So also when the noise is measured in the co-spy method as indicated in 117, the major dependency is on the tread itself and the casing itself has very low impact. Also here we can stay in the same labeling scheme as already applied for new tire. The tricky part, as I already mentioned, is the rolling resistance, because the retreader needs one raw material, let me call it like this. The casing he hasn't got an influence on, and as we found out in the recent tests performed by ETRTO, measuring about 300 to 400 different tire sizes and tire brands, that there's a huge spread between up to 3 label classes, why the rolling resistance labeling system cannot be applied in the same way as it is today for new tires. So there are 3 major influences on this critical rolling resistance schematic. That's the casing itself. Then you've got the manufacturing process, which in many cases, especially on the SME side, is not a fully automated one, as it would be on the new tire side, but a lot of craftsman input and manual labor. And of course, the tread itself, designed by the design of the tread, the pattern and the compound properties. There you see about neutralized, of course, because we don't want to discredit any brand here. The variety of different rolling resistance value we have measured depending on the individual dimensions we assessed in the first instance. And you can see that the casing is a major variation source for rolling resistance with a very high standard deviation of about 0.35 Newton per kilonewton. If you put also into consideration the influence of the variation in the manufacturing process, such as buffing radius, curing temperature, and cushion gauge, you have also an implication that will turn up in the standard variation as realized about 0.28 Newton per kilonewton. And if we sum up this in the normal mathematic way, you will find out that the sigma totals, the standard total variation, adds up to about 0.45 Newton per kilonewton. And therefore, we needed a bandwidth of the labeling class for rolling resistance of about 3 times of the external variation, which turns out to be 1.5 Newton per kilometer, and a bandwidth tolerance of 0.7 Newton per kilometer, which is technically needed compared to what you all might know, the bandwidth for the new tire, which is 1 Newton per kilonewton, 1.0 Newton per kilonewton. So how to deal with it? First, we have to separate the influence of the casing itself, and then we have to manage to measure in a certain way the influence of the tread and the process. So this is a schematic where you say you take a casing from a used tire, you retread it, you measure the retreaded all-over rolling resistance value, then you buff it into a certain defined way, and then you make a deduction of the 2 values to find out what the influence of the tread and the process is. So compared to wet grip and noise, where we said we can say in the same labeling schematic as for new tires, for the rolling resistance, in our opinion, there's only one possibility to make the bandwidth of the classing a bit wider as it is for new tire. And you see the schematic on the right side, where we compare to the new tire side with a bandwidth of 1.0 Newton per kilonewton. We propose to have a bandwidth of 1.5 Newton per kilometer, and to differentiate between the rolling resistant class of a new tire and the retreaded class. We didn't call the classes A, B, C, D, and E, but RA, RB, RC, and RD, which are defined by these measuring values you see there. And also to reduce the effort and the financial burden generally for the industry, our idea was to focus on the major 10 to 12 tire dimensions, which are in the retreading field in Europe, are representing about 90 to 95% of the overall retreading market. Come to the conclusion, and that was basically the contents of our proposal. We did several times now, discussed with the Commission, and which is now into a review process. That means the Commission set out a tender to an independent technical service whose task it was to review our proposal and see whether it's reliable, whether it's consistent. And then the next step would be to include this labeling scheme by delegated act into the European Labeling Regulation 740/2020. But taking the time into consideration we needed so far and the time we have to expect to be needed till that's really all settled, together with the transition periods which are needed for the industry on the material manufacture side as on the retreading side, to prepare, I don't see it personally realistic to see a labeling being enforced before 2026. And that would then mean that we nearly needed 10 years to get this done, which shows a bit, the desperate task we sometimes have to do. But as I said here, we're totally in line with the new tire industry, so it's a hand-in-hand operation. And I would also like to thank all the people who are participating in this work. And we now have to wait to the results of this review process and see how we can continue with it. That would be it from my side. If you got any questions, I'm fairly happy, of course, to answer them. Thank you.
Right, thanks, Michael. That was great. I see there are quite a number of retreaders in the room, and as Michael finished his presentation in 15 minutes rather than the allotted 20, I thought it might be a good idea if I open it up to the floor now for any retread. If there's anyone out there from the retreading sector who'd like to ask Michael a question, please raise your hand and we'll send a microphone out there and you can ask the question. If anybody would like to say anything at this stage?
Don't be shy, I'm not biting.
No, well, that seems to have, everybody seems to have understood that fully then. Fantastic. Okay, so there's been other opportunity at the end of this first session to ask Michael some questions if you would like to. Okay, so let's move on to the second speaker. Thank you, Michael. So let's move on to the second speaker. This is a completely different topic. The second speaker is Krzysztof Wroblweski, who's the CEO of the Polish pyrolysis operator Contec. And Krzysztof's presentation title is The Way to Circularity in the Automotive Industry. So, Krzysztof, please take the stage. Thank you. Sorry? Yeah. Yes, you can. Yeah, of course. Yeah.
So thank you very much for a kind introduction. As you heard, my name is Krzysztof Wroblewski. I'm CEO and CTO of Contec, and I will take you for the journey about pyrolysis and what we can do to improve the circularity in the tire industry. Okay, but maybe you didn't heard about Contec, what we do. We are the operator of 2 pyrolysis lines, and we have running for several years technology demonstrator, which has the capacity for 12,000 tons of end-of-life tires per year. The plant is located in Szczecin. It's near the German border, northwestern part of Poland. And we are a unique technology developer. We didn't bought our reactors somewhere else in Asia. We developed the technology from scratch, and we are the only one in the world using molten salt as a heat transfer medium, which brings certain advantages. But I don't want to get very technical because this is also retreading business conference. That's why I will try to be as broad as I can, so everybody can take something from this. But R&D started in 2014, and we designed the plant throughout the years, and the pilot plant is in operation for more than four years right now. And we completed the fundraising round for 15 million euro to further expand our capacity. And the project is in schedule and in budget, hopefully, and will be starting first half of next year. New locations are in evaluation, so we'll scale out the capacity further down the road in Europe. But if you can imagine, and even today, if you go to one of these halls here at Future Motive Conference, you'll see Michelin tire, and this Michelin tire is made from 68% of sustainable raw materials. It's a demo tire, and with all these existing technologies that we have really right now, we can easily match 30% of sustainable raw materials as an input for the tire. The only issue right now is the scale and the availability of all these resources. So we can go with circular steel from tire shredding. We can go with circular RCB, and I will tell you something more about that in a minute. We can go to circular sustainable virgin carbon black. I'm pretty sure you know carbon black itself, but you can make this carbon black from different feedstocks, and usually it's being made from very nasty fossil oils, but you can make it circular if you use tire pyrolysis oil as a feedstock, and this is being done right now. And also you can use circular rubber powder, because everything that can be mechanically recycled should be mechanically recycled. But here I represent chemical recycling, and this is second step for the recycling. And I will tell you about 6 very important things how to make it really feasible in terms of chemical recycling. So what recovered carbon black industry needs to succeed in bringing circularity in the tire and rubber industry. So let's go with this. I have 6 points, and I hope you will stay with me for all the 6 points. So the first one is operational excellence. Usually pyrolysis companies are very small companies. We are technology developers, and then we try to validate the technology, and barely some of them in the world gets to the point where we have actually running industrial plant and have some operational excellence. So proper design, safety protocols, team training, process control are essential, and maintenance as well are essential to turn the idea into industry. So the whole organization changes. Right now in Contec we have like 70 people, and most of them are running the process, and this is not R&D anymore. The second part is about actually quality and R&D, because recovered carbon black industry is being still under development. We just try to find new methods how to characterize recovered carbon black to be sure that we can put it back to tires. And this is being done. Contec is already accepted by major tire manufacturers for their feedstock and inliner applications. So this is working, but it can be done only when you have R&D team and quality control team in stock. And even if you have team, you also need the laboratory, of course, because you need to invest in laboratory to measure all of this data and all of these parameters in-house, because if you don't have in-house laboratory, you will outsource everything and you will wait months for the results, so you will have no contracts. So you need to change all the business around this from being technology developer to actually producing something, yeah? And also, this is something different if you have R&D, and also something different if you need to have response and quality assurance procedures, because tire manufacturers are being really used to somebody who has like 200 people in the quality department and all the certifications. The small companies that really take care about the pyrolysis right now, they don't. We are one of the first one actually to build quality schemes in Raw, and there are like 5 or 6 companies that have ISO certification for the quality. So this is still a challenge for pyrolysis industry, but we'll do it. And the third thing is about auxiliary technologies, because I'm sure most of you that really know pyrolysis knows it for, I don't know, 10 years, 15 years, but the quality was not there. And not only the quality was not there, but there was no auxiliary technologies that could bring this recovered carbon black back to tire, because first you need to mill it, then you need to pelletize it, and there were no actual providers of technologies that could reliably do it for you. That's why it's really needed by the industry that these all auxiliary technologies, shredding, milling, pelletizing, drying, are being developed, so we can go with higher capacities, with lower maintenance costs and higher safety solutions as well. So also, apart from just being purely operational, there are quality standards. Like I said, we are just developing the methods how to characterize our products because they are so new. And there's huge progress in ASTM D36 committee, which we're working on to characterize end-of-life tire products, tire pyrolysis oil, and recovered carbon black as well. The fourth thing is the feedstock control. I think it's something that can be copied in all businesses, because if you put garbage in, you will have garbage out. So feedstock control is very important. And because of the change of how tires are being manufactured, we'll have the change in what are the products of the pyrolysis itself. Because I'm sure you know, when you're in tire business, tire manufacturers are putting more and more silica in the tread itself because of development of functionalized SBRs. And we made a test. So normally when we use end-of-life tires, mostly PCRs in our operations, we have like 25% of ash content in RCB. But because of the silica content increase in the tread, when we pyrolyzed new tires that didn't meet quality control from tire manufacturer, we've seen the ash content for 35%. So we ask tire manufacturers, how do you want us to make lower ash content in recovered carbon black when you put so much silica in the tread? It's just impossible. But nothing is impossible. We find a solution for that, but I will tell you in a second. But this will be a long-term trend in European Union, and we'll see that average ash content will rise during next few years. So it's really difficult to get the contracts when you said, okay, in specification we have 25%, but we expect that in 2 years from now we'll have like 28, and maybe in 6 years from now, because those tires are already on the road, I will have like 30 something. So this is something really difficult. And this also influences in-rubber performance of recovered carbon black, because right now we are easily in the N660 range, so we are okay to be put in sidewall or inner liner compounding, but not in the tread. But if you have much more silica, it will be difficult for the sidewall to get involved. So what are the possible solutions? Of course, if you put more TBRs, there are less silica in the tread, so you could push your pyrolysis with more TBRs, but TBRs should be retreaded. You're all talking about that today, so this is the right way to go with TBRs. Of course, we can try to separate the minerals out of RCB, but this is dangerous and very not cost effective. But we chose different approach. So we went to sidewall and carcass specific pyrolysis with our partners. We partner with Tire Recycling Solutions, a Swiss company, which takes the tires, cut the sidewall off, and then they use their own technology, which is called Tyres water pools, to shave off the tread with water jetting, basically, to micronize and to create some kind of powder. This powder is called Tyrexol and can be used directly by tire manufacturers in new treads, maybe also for retreading. I highly encourage you to approach them if you're making compounds for retreading as well. But there is sidewall and carcass left, so we can use it. And we did pyrolysis with very specific feedstock from just the pure sidewalls, and we had really great results with resulting RCB with lower silica content, high reinforcement, and really good results. What else is needed? The number 5 is market traction, because most of small companies have no cash flow for high capex, and if you want to sell recovered carbon black, and you can see carbon black at the lower part of the image, you need to invest a lot in the so-called RCB finishing line, and this is really difficult, because on one hand you have substantial demand, because every tire manufacturer right now is going to chase you after recovered carbon black, because there's not enough in the market, the prices are high, but on the other side it's really significant capex, and it takes almost 1.5 years to build a proper finishing line, like we have one in Szczecin. So at the end, this number 6 point is sustainable business, because it was extremely difficult that year and previous year to get financing for this type of industry for scale up, and we need to work together. I believe the collaboration is the way to go. So we need economy of scaling in chemical recycling. That plastic pyrolysis is leading the way, because everybody right now from the plastic industry and plastic pyrolysis industry is expecting that the off-takers will pay higher prices just to develop the capacities for the pyrolysis industry. So there are several things to consider, and we need clear guidelines as well for LCA, because everybody is presenting, like we do present for recovered carbon black, that the carbon footprint is much lower, but everybody is calculating this in a different way. So most probably you are also asked about what is the carbon footprint of retreaded tire and how to calculate this. We need really clear guidelines for LCA studies and the carbon footprint, and we are already doing this in task group in Chemical Recycling Europe, so this is being done. I will not talk too much about all these points, because I think my time is running off, but I told you already about the fundraising from completed, so we're very, very happy with that part, and this will increase the plant's capacity. So we'll hear more about Contec in the future, and I think I have a call to action for everybody involved in the tire manufacturing industry. I think we should share this call with retreading industry, that we need expressed demand, because each declared kilotons of RCB or your products really matters. If the tire manufacturer is saying loudly and publicly they want to buy it, it's much easier to get financing, because venture capital and private equity investors are not the insiders of sustainable raw materials business. So it's not that very easy to assess these cases for them. So what also we need in terms of recovered carbon black is really industrial volumes, and this is ultimate goal, because we right now produce several thousand tons of recovered carbon black per year. When we approach tire manufacturer, they want to start with 5,000 tons per year just for one plant. And we are, too small for them and too big for different players, that we need to invest and scale up. That's why I think this kind of collaboration that I told you about is a must. So you can meet us offline. We're all invited to visit us at our plant in Szczecin, and you can meet us online as well. Find my LinkedIn. Thank you very much for attention.
Has anybody got any questions for Krzysztof about the pyrolysis sector before we move on? You're all very quiet out there. Are you sure you haven't got any questions? Ah, there we go. John, Powath.
Krzysztof, just a thing, the retreading, do you see that you can actually use the RCB in pre-cure threads or more-cure threads, or will it only go in sidewalls?
Yes and no. Right now, I don't think so. The main goal for recovered carbon black right now would be sidewall and inner liner, because it's much easier, and the RCB mostly behaves as an N660 in most applications. But on the other hand, there are R&D going on about the activation of recovered carbon black, and we see first promising results to activate recovered carbon black to get it more, I would say, reinforcing. And if it's more reinforcing, it can be added in thread, because usually in thread you use N330 and more reinforcing grades of virgin carbon black.
Thank you. Just one more question is, what happens if silica content starts going up in the threads? Do you see that going to be an issue on the quality of the RCB that will come out?
Of course it will be, because we can see that silica after pyrolysis is not active at all. That's why the reinforcement will drop. Therefore, we try to find a solution, and one of this is our collaboration with Tire Recycling Solutions to shave off the thread and make it pulverized, and then pyrolyze the rest of the tire, because it will guarantee that the stability of the feedstock, yeah? Because in the carcass and sidewall there is much less silica content, and the variability of, generally speaking, minerals in those parts of tires is much, much lower.
Thank you.
Thank you very much. Oh, one more question here.
Thank you. Just a short question. Sorry, in pyrolysis process, typically there are three kinds of output. There is gas, which is used to feed the process. There is carbon, which is your raw material. And then there is oil. What do you do with oil?
Okay, so oil, as I said, could be also circular. And we have several applications for the oil. The easiest one, of course, is industrial heating, because it's very calorific, but this is not recycling. If you use something for energy purposes, it's not recycling. Therefore, we work with global manufacturers of tire processing oils, so we can use mass balance approach to use tire pyrolysis oil as their feedstock for the refineries, and then try to make tire pyrolysis or tire processing oils for the manufacturers. The other application would be to make sustainable virgin carbon black. So instead of fossil feedstock, you could use tire pyrolysis oil by Orion, Cabot, Birla, or whatever who produce virgin carbon black as a feedstock for the furnace. And then you create sustainable virgin carbon black, which is exactly the same in terms of parameters as virgin. So it can be used in the thread, for example, but it's with much lower carbon footprint, and it's circular because it's made from the oil made from tires. Okay?
Okay, and any other questions before we move on? No? Okay, well, I'm sure there'll be time later for further questions. Thank you very much, Krzysztof.
Thank you very much.
For a very clear description of the dynamics of the pyrolysis sector. Thank you very much.
Thank you very much. If you...
Okay, so our third speaker today has come from Canada, and that is John Visaisouk from Tyromer. Now, John's company is in the devulcanization sector, and when I talked earlier about crossover topics, John's company is, of course, in the tire recycling sector, but he's going to talk about today about moving towards tire-to-tire recycling, reality of circular retreading, and he's going to talk about the application of his company's devulcanization process into a circular retreading concept. John.
Thanks very much, David. Really appreciate it. All right. Hi, everybody. Thank you for having me today. Thanks, David, for organizing this. So, you know, a lot of this stuff in the last presentation is actually quite relevant to our technology as well, to devulcanization. And I think it shows that, despite whatever type of technology it is, the recycling sector in general really needs our support right now. And so today I'd like to talk to you about the future of tire recycling and retreading. For us, that means tire-to-tire recycling through our concept of circular retreading. Now, what I call circular retreading, basically using the retread buffing dust or the retread waste as feedstock for pre-cure and mold cure retreads. And we do this through our process called devulcanization. And so really in this method, we're taking the retread buffing, the retread waste, and turning it right back into new retread material. And so I'm going to describe the steps to go through this. It's quite straightforward in the sense that we don't change anything of the first step of retreading. So you look at standard truck, bus, OTR retreading. The tires are buffed down, meaning the old tread is removed from the tire for the most part, and so a new tread can be glued on or molded on. But we really use this buffing dust as our feedstock. Now, I'd like to make it clear that the devulcanization technology works with a large amount of feedstocks. Basically, any material that's been cured with sulfur, we have the potential to devulcanize. But for this particular presentation, we're talking about retread buffing and, again, circular retreading. So step 2 is really the devulcanization step. So after you have this retread buffing waste, it goes through our clean process of devulcanization. So basically, we're using a twin screw extruder. It's a thermomechanic reaction. We actually do not use any chemicals at all. And so it's just the retread buffing waste that goes into the machine. And it's this, we call it tire-derived polymer, or TDP, that comes out. Again, there's no chemicals used in our process. There's no additives. Now, this is a really old video. This is a 10-year-old video. You can see the chrome rubber falling into the extruder in the middle there. I like to use this video because it really shows the simplicity of the technology. Like, that was the chrome rubber going in, and this is the devulcanized rubber coming out. And that's the whole manufacturing process right there. It's a really simple process. Now, since here, this was about 10 years ago, since then, we've really developed a lot of downstream processing, like automatic packaging, metal detection, weighing and cutting. But the actual devulcanization process, that was it. The chrome rubber goes in, it's a thermomechanic reaction, and this devulcanized rubber is what comes out. Now, step 3, once we have this devulcanized rubber, what do we do with it? Well, we take it and we mix it into a rubber compound. And so this could be a mold cure, this could be a pre-cured tread. It's also important to note that our material, because it comes from basically the retreaded tires, it inherently contains about 26–27% recycled carbon black. So while we talk about our material being recycled rubber, it's really a recycled rubber compound that contains natural rubber, synthetic rubber, and carbon black. And so again, just using our material, carbon black as a filler, it's really not, it's really the vulcanized rubber that gets in the way of reusing that carbon black. And so by devulcanizing the rubber, it makes it a lot easier to mix in. And so again, our material is inherently about 26 or 27% recovered carbon black. Now from there, we mix it into a retread compound. Again, this could be a pre-cured compound, this could be a mold cure. In this case here in this picture, this is a mold cure compound. And so in terms of the addition level, we look to add maybe 10, 20, or even 30% recycled content into a new retread. And it really depends on the application, but still that's the potential here, is using 10, 20, or even 30% recycled content in a quality retread that meets industry standards. And so for the application of it, this is for mold curing. And so this was actually the first big application that our TDP was used in Canada. And so there's a big company called Tire. They do a lot of mining services. They've been a partner of ours, and they've been using this OTR retread compound for about 6 years now. And so they started with 18%, using 18% recycled content. And just this year, they were actually able to increase the recipe to 25% recycled content. So these tires that you see here, these are newly retreaded OTR tires with 25% recycled content in them. And the recycled content is the rubber compound, basically the rubber and carbon black mixture. Now, we're doing the same thing for pre-cured tread. I'd say the development is maybe just a little bit behind it because this is just starting to come out now. But these are basically, it's the exact same method and process. So basically, you're making this pre-cured compound. Again, 10, 20, 30% recycled compound. But for this application, for a pre-cured truck tire tread, we're looking at more at that 15% range is probably right now more the optimal level. As the tires get larger, we seem to be able to add a little bit more recycled content into it. But for a pre-cured truck tread, we should be targeting 15% recycled rubber compound right now, because this is basically what we've been doing the last few years. Again, I think a lot of the comments that Krzysztof made in the last presentation make a lot of sense, because us too, we have been working very closely the last few years in quality control, controlling the feedstock, opening up the market. So again, these concepts are not just related to our technology, but to the tire recycling industry in general. And I think, of course, events like this are great to bring more attention to it and to bring the right minds together. Now again, this is something that we've been doing in Canada since about 2016, and so we can say now over about 15,000 OTR retreads have been made with this compound with 20% recycled material in it. So this is something, again, we've quietly been doing this in Canada, but it's been ongoing for about the past 6-7 years now. And so again, we've passed about 15,000 OTR retreads with about 20% recycled material content. So a little bit more about this tire-derived polymer. So again, it can really be made from basically any rubber material that's been cured with sulfur. So our most standard is retread buffing. We started with retread buffing because it's very finite. The truck TBR, retread buffing specifically, very finite in terms of the composition. It's pretty standard whether you look at the truck tire composition of Europe to North America, even to Asia, they're relatively similar. So we liked retread buffing because it gave us a very narrow range to start with. From there, we've really standardized whole truck tires. So we have a whole truck tire product. We can also do a whole passenger tire product, but it's a little bit lower quality. So right now, our main sources of feedstock will be 1, the retread buffing dust, 2, end-of-life whole truck tires, and 3, end-of-life OTR and giant mining tires. Those are actually incredibly, very lots of, great amount of recycled rubber in those big tires potentially. But we can also do factory scrap, we can do factory reject tires. The technology has the potential to devulcanize other synthetic materials like EPDM. But again, right now we're really focusing on the retreading. And this is actually, again, the longest standing application that we've been into. Now, as Krzysztof was mentioning earlier, it is very important to control the feedstock. To be able to supply the tire industry and the tier 1 manufacturers, you really need to have your QA and QC in order. So, you know, we have ISO 9001, the 2015, the ISO 14001, and these are really just the start. Now, benefits of using tire-derived polymer, well, we think it really significantly reduces the CO2 impact or footprint. So if you make TDP instead of making a new tire compound, you will save about 90% of the energy. The devulcanization process is quite simple, as you guys saw. It doesn't have chemicals added, no additives, and the energy efficient process uses about 300 kilowatt hours per metric ton produced. Now, TDP can be basically always sold at a discount compared to natural rubber or carbon black or something like that. So it definitely will reduce costs. We like it because we prefer to produce this locally. So the whole point of our technology is to license the technology and get it out there to where it's needed. So if we need this in Italy, we want to put a facility in Italy. If we need this in Australia, we want to put a facility in Australia. The point is to use local material and have a local source. You can use those local tires basically as a local source of rubber. And so in places like the United States and Europe where we do not grow rubber, we can still have a source that is largely natural rubber coming from these end-of-life tires. And as I said, this TDP is actually currently already being used in these applications. So it is being used in new passenger tires right now. It's being used in retreaded truck tires, that's pre-cured. It is being used in OTR retreads as mold cure. And it's actually also being used in some conveyor belt applications. And so it's really a versatile material. It has a lot of potential in it. And right now we're just trying to get the word out and let people know that this is possible. Now, beyond just regular tires and retreading, just as a quick thing to show, the material can be made, into a lot of different parts. So these are example parts that are made with 100% recycled material. These ones up here are made out of whole truck tires. So again, the material has a lot of potential. These are some more products made with portions of TDP being used. And so again, we really think it's a versatile material, but in this case, retreading is really where we think we can make the biggest difference quickly. And so just a little bit about Tyromer Inc. As David said, we're a Canadian company, so we're founded outside of Toronto, so in Waterloo, Ontario, about an hour west of Toronto. We are a licensing company, so we want to license the technology. We don't want to be setting up and running all these facilities ourselves. We want to be capitalizing on the strengths of partners and being able to keep on our own technical expertise. We're really a technology company, so we like to continue to develop the technology, find ways to increase the properties, find ways to make the process more stable. Right now we have 2 facilities in Canada. We have a facility in Arnhem in the Netherlands. There's a facility coming to Chennai, India next year, early next year, and there's a few more in the planning stages. So hopefully we have something else in the United States and an additional one in Europe coming soon. You know, in this for this audience, I thought it was important to kind of mention what can people do to help right now. And again, I think a lot of the points Krzysztof made were really spot on in terms of the support that we're looking for. And so, you know, for individuals, we want the consumers to start requesting recycled material from the tire manufacturers. That will eventually start to change the way that they work. If their customers are demanding it, then eventually they will change. So that's something that can happen. So individuals, consumers can do this. If you're a fleet manager, that's a perfect job. That's a perfect thing for you to be able to root for. You know, we think local jurisdictions can promote recycling more via grants, startup programs, direct subsidies, you know, things like that. Large-scale government, and we think this is coming here in Europe relatively soon. There will be legislation, I'm sure, for using more recycled rubber in products like tires and retreads. As soon as it becomes basically doable in the market, which it is now, so as soon as the market supply is there, we believe this will be coming. So in the next few years, we expect there to be recycled rubber mandates coming in multiple jurisdictions. I like to use an example of the Renewable Fuels Act in the United States. It was actually one single state of Minnesota that started the Renewable Fuels Act. All the big companies, Ford, GM, they said they couldn't do it, but they passed it anyways, and now basically 15% of all the gas you buy in the US or North America is like ethanol or kind of the recycled, the green material. So it is definitely a kind of a path that we can follow there. And private industry, we really want to accelerate the development. I think that the potential and the proof of concept has basically been proven. And so now we're looking to basically create this supply where we can actually supply the tire industry in large levels. And so we want to accelerate recycled rubber compound development and in terms of usage and application. And so we want to take the first steps today, so in the future we are running with it. And this is just a small tour of our facility in the Netherlands. This is in Arnhem, the Netherlands, so a couple hours outside of Amsterdam. So it's on a clean tech campus, but this is our Tyromer Europe production facility. We call this kind of our facility 2.0. This really is it's really a showcase facility. It's not a true manufacturing facility. This is really a place where we want to bring people, show the technology off, get people comfortable, and provide material as much as we can. But really, it's a showcase facility. We do have 2 ISO certifications. We have a full straining capability, which is basically forcing the hot rubber through a fine mesh screen to remove any contaminants. We have metal detection as well. Full QA/QC lab. We actually have 2 extruders here. So we have our main extruder, the 90, is for our standard tire material. We have a smaller extruder, the 60 millimeter, which is good for synthetics, specifically things like EPDM. Again, we have this full straining capability. This is really important. I don't want to brush past this point. This is really important for quality in the tire industry. So basically, as you go through the crumbing process or as you get the retread buffing dust, there will be a little bit of contamination, whether it be some metal or wood or stones. There's going to be something in it. So basically, we force the hot rubber through a very fine mesh screen to remove any of those contaminations. This is a really important point for breaking into the mainstream tire industry and tier 1 manufacturers. So while we we are doing this in all our operations now, we believe that, basically any recycled rubber going forward is going to need to have some kind of straining mechanism or some kind of quality standard, such as this straining. So we have automatic cooling, drying, and cutting. So basically, we'll go through a metal detector. It'll weigh out exactly a 10-kilo sheet, plus or minus, a couple of percent, and then it'll automatically stack the material. We check for metal. This is very important. So there's metal checks at the beginning and magnets through the system, but this is one very final check before we stack the material. We check it for metal one last time. Again, quality and tire industry go hand in hand, and so this is something that we've had to spend a lot of time on in the last few years. Again, full QA and QC lab. So like any other product, if you order from us, it comes with a certificate of analysis. We can agree on whatever specifications we want to together, but we have the full lab to provide it as well. And so in conclusion here, really, this concept of circular retreading, it's not just a concept. This is actually happening right now. We're doing this right now, and we feel like we can do this a lot more. I think the support in Europe is particularly good for these kind of activities. Retreading can really make a difference. We've seen that, and now this kind of takes it a step further by using the own retread waste to go back right into these retreads. And so again, as a licensor of technology, we would love to continue to discuss with partners. So if you have a need for material, if you're interested to learn more, please come and talk to me. Thank you.
Thank you very much, John. Much appreciated. Has anybody got any questions for John? Please. Yeah? Yep. Sure. Okay.
Thank you. Yeah.
Hi.
Good afternoon, John. What is the approximative amount of investment that's required to set up one of your factories? And what is the volume of production required to
good
reach
question.
the break-even?
So our standard facility, our standard machine would be about 4,000 metric tons a year. And, give or take, depending on what you need for downstream, I'd say your price is around 3 million USD. Again, I can discuss specifics with you, but that's a good ballpark to use. Welcome.
Anybody else? Nobody else at the moment? Okay, at this point then, thank you very much, John. Appreciate it. Thank you. At this point, what we're going to do is we're going to switch everybody over. I'm going to ask the three current speakers to take a seat in the audience, and I'd like the four remaining speakers, that's Riccardo and Enrico, John and Brian, to come and take a seat. Thank you. We're going to carry straight on. So that we can get maximum time to set up the stage for the Recircle Awards afterwards, and also to give you maximum time to have a drink and relax after we've finished. Okay, so our fourth presenter today is Enrico Fiore, who is the CEO of Truyoins Limited. How's it pronounced? Yes? Yeah, okay. Thank you very much. Okay, so Enrico's presentation is called Tire to Tire, the True Virtuous Circle of Tires. So this is about it's just another crossover presentation, really. It's about a new retreading concept developed by Rover Research, about the use of H2O devulcanization technology. Enrico.
Good morning, good afternoon. I want to use for this presentation the real pitch that the CEO of Rover Research done to us about 2 years ago. We are an early stage venture capital. Our headquarters is in Israel, Tel Aviv. We have a branch in UK and in Italy. We support impact startups, only impact. We work on the steel, slag recycle, we work in the fashion recycle, and we work now in the tire recycle. But we start with the retreating process. Why? Because we understand that in Italy, not only in Italy, in Europe, there is not so much retreating tire. Only 20% a year is the tire that go to retreating. So, what's happened? I'm sorry, this is the slide that we use the CO. We have a bottle, 100%, full, drink a little bit. And we go to waste. Why? Because when you use a tire, after 10% or less, you take away. So, happen that in the trailers that have a 6 tire at least, you put this. 80% go to produce or energy or other type of powder, but do not come another way in the same tire industry. Why not? We can do the same. Water is the same that I take an apple. Good. And also, you take out 90% of the food. Why? We do not have to waste the things. No. We are a killer technology for the retreating because we present a new concept of the retreating. You can find now what is the traditional retreating system and the rover research retreating system that use a special water jet machine that devulcanize the surface of the tire. And so we can retreat with at least 30% of raw material that we saved. So we save 30% of raw material at least. And you know exactly how is the cost of the rubber. So what's happened? That using our water jet machine technology, we have created some powder. And thank you to John that before talk about the rubber and the process that with Tyromer they work. Why? Because, I'm sorry for the gadget. Oh, don't worry. I use there. Because we have this, here's the powder. This is what's happened when we use our water jet. It's dry. And you can use directly in the retreating of your tire. You don't need nothing more. So what's happened? That we start with the retreating technology, and we discover that part of this technology can be used also to recycling the same rubber. So with one process, we have also a great secondary raw material, just ready to use. We just use today in Italy, in a OTR plant, this type of tire dust in at least 15% inside the retreating process. We just develop a type when we can use 50%, and thanks to our partner for the Italian market, that is Powath, that is a consortium of tire, we can push also in the market of the recycling of the end-of-life tire, because what you saw in the video is a container 40 feet. Inside we have all our technology that can work 800 tons a year, so it's good also for a medium, small plant, and can produce more or less 600 tons of tire dust. The other is steel. And this can be used to produce new tire without problem. So you can see in our boat what is the transformation H2O, and this produces power dust, the tire dust, the steel, and we have a 3% of waste. But with this type of process, we have energy saving. We can have an increase in durability of the tools, and we can improve the productivity of the plant anyway. There is some Q&A and QC that we've done with the Italian certificate laboratory, and we are sure that this can be used today. Oh, also, we just used from 2017 in Italy this type of technology, this type of secondary material raw. So I think that we have to try different, and we have to approach with what we call as a VC a second horizon. And I think that in this place, with the different technology that I have saw, and there is a lot of great innovation, I think that can start the second horizon also in the tire industry with a real circularity. A real circularity is when the same material is reused in the same sector, not when you can use this material to burn, to produce energy or other. So you have to use the same material in the same sector. Is what we do in the steel recycling process, is what we use in the fashion process, is what we want to use in the tire sector. Thank you.
Thanks, Enrico. Has anybody got any questions, please? No questions at all? No?
Great.
Okay.
It's clear.
Yeah, everything's clear, yes. Okay, thanks very much, Enrico. So now we've seen three different types of tire recycling. There's pyrolysis, there's normal devulcanization, and there's the H2O demolition. So all very interesting. So let's move on to the next speaker. The next speaker is Riccardo Giovannotti. We're going to change the subject a little bit now. Riccardo is the Secretary General of the GDSO, which stands for Global Data Service Organization. And Riccardo's presentation is called Beyond Tire Identification. And we're talking about the latest developments in the management of tire data in the process of optimizing the life cycle of the tire. So, Riccardo, thank you very much.
Thank you, David, and grazie to everyone to be here today and for this opportunity, and grazie for being here in Bologna. I hope you may enjoy the food here, and as an Italian guy, I'm pretty proud of that. But beside that, let's say, we heard a lot of very important thing up to now. We talk about feedstock, we talk about quality control. We heard about a new horizon as well. Let's try to make a step back first. So let me introduce GDSO first. So GDSO stands for Global Data Service Organization for Tires and Automotive Components. It's an international, non-for-profit organization made of tire manufacturers. As you may see, among our members, there are, let's say, the biggest brand around the world, so that we can cover mostly all the world with those kind of premium tires product. But we have also some associates, meaning technical partners like ETRTO, JATMA, TRA, TRAC, USTMA, because we want to be a global player taking into account local input so that we can have really a local approach. And my name is Riccardo for sure. But let's say why GDSO exists. Let me start with this movie. We heard a lot about tire information, about identity and so on. And we know that many critical information and data are stored on the tire, into the tire, but very often it becomes a nightmare to retrieve this information for many different reasons. First of all, because they can just peel on a sticker that can be easily lost, or just because you need some visual check. And it can happen also during the retreading operation. You have to spend time, you have to go there, and possibly you can make some mistakes. It's a stupid one, just reported here, but you know, mistakes may happen, but it's not just a matter of mistake, it's a matter of optimization, delay, and waste of profitability for all those involved in the tire value chain. So the question that we posed was how to solve the problem. And the answer is in GDSO. That means we decided to start providing a unique item identifier, so a serial name to every single tire around the world, and to get it so that it can be serialized, unique, and unfalsifiable. But then the question is still there. How can we try to move from, you know, a kind of analogic approach to a digital one, meaning to scan the tire and then let the data flowing back to the user? And the answer that we provide is to use the tire information service. That is our platform. As I was saying, I'm making a step back compared to what we are talking up to now, because really the tire identification is the starting point for optimizing any kind of operation, including the retreaders, but also the end-of-life tire management and so on. So that's what we are talking about. That's the GDSO, the tire information service solution. So what we think is that every players along the tire value chain may get benefit of a data-driven approach. So a tire identity can be captured, GDSO solution can be interrogated, and data can be obtained in a digital way. But how does it work? As I was saying, starting from a serialized approach, so a unique name for every single tire around the world, a passport number is provided, and then it is captured by the user. It's captured, our service is interrogated by the user itself. We provide the information to the user about the tire manufacturer that shall be interrogated, and then the user is going straight forward, in this case, to the tire manufacturer C. So among many different tire manufacturers, it's not the A, B, D, E, it's the C1, where it's going to knock to the door with the token we provide, and then data are flowing back based on a B2B agreement. And really, it doesn't matter if it is a brand new tire or it's a used tire, like in the case of a retailing operation. The target for us is that all this kind of information can be made available along the entire value chain and for all the stakeholders along the tire life. So it's for tire manufacturers, for vehicle manufacturers, for logistic distributors, it's for quality insurance, retreaders for sure, up to the really end of life. So it's a very complex, let's say, environment, but we found a way to make it simple. Don't be scared about the picture. I will not deep dive on that. I usually use this picture to explain what GDSO is not. So try to follow me so that we can then explain what GDSO is. So GDSO is not a central database. As you may see on the sketch, okay, trust me, on the right side of the monitor, you may see the database for every single tire manufacturer around the world. On the left side, bottom side, you may see the user. So GDSO is in between, is a kind of traffic ruler. But we are also the trust center, the one that is saying to the user, it could be a retrader, don't be scared. The information that you're looking for is provided by that specific tire manufacturer, like the tire manufacturer's B in the bottom right side of the sketch. And the tire manufacturer, once he's interrogated, has got the trust on GDSO that the interrogation is made on purpose, is not just a bot, and is not just letting them wasting time. It's really for optimization of different operation and to increase the efficiency. And then data are flowing back. So as I was saying, GDSO is not a centralized database. We have no visibility of the data itself. What we are doing is to claim to be the reference data platform so that we can simplify the data exchange and the, let's say, digitalization in the tire industry for both user and tire manufacturers. And now let me say then what GDSO is and what the tire information is. Possibly you heard now there is a lot of rumors about data spaces in Europe and all around the world. And we claim to be a data space. Why? Because what we provide is an API, so an application programming interface. We are not just going knocking at the door of different users and say, hey guys, you have to use our software because it's better than the others. We say, guys, that's free of charge. It's in an open environment. That's the codes of line you have to implement, and you can retrieve it on our website. We provide a structured list of data, and based on standardization, we grant interoperability. It doesn't matter if it is the tire company A, B, or C. Everyone working with GDSO may let their data be available and flow around along the tire value chain. But also, as I said before, GDSO is not a central database. Data sovereignty still remains into the tire manufacturers. So we have usage policies, we have authorization and authentication rules in place. The last but not the least, as I said before, the GDSO is the one granting trust and security among the parties. So let's say, what's in it for the retraders and for all of you today? As I said, up to now, I was making a step back, saying that possibly, first of all, we have to identify what is entering into a retrading facility. Why? Because it's a dirty tire. It's something that is not nice to touch, to play with, and digitalization is something that may definitely improve the efficiency of retrading operation, but also for the ELT, for the end-of-life tire management, the improvement of the feedstock quality, for example, because a more homogeneous feedstock can be created, and all the other presenters that you heard up to now, I guess, would be more than happy to have that kind of level. So in a kind of a from cradle to grave approach, others presenters that were here, like Michael, and I see many others in the room, were interviewed by us. And they were answering the question that is very simple, but it's a kind of a $1 million question. What do you need to know from a tire? As soon as you got a tire entering your facility, what would you like to receive as a key information? So based on that, we understood that, let's say, usually during the tire life, there are many challenges. Because if we provide a unique identity to the tire, a lot of major events may occur as well. That means the tire can be damaged and then repaired. It can be retraded. It can be recycled. So that kind of identity shall take into account all these kind of major events so that different players may take into account the history behind the tire, but also the tire manufacturer may perform a life cycle assessment of the tire itself. But again, as we heard before, in the digital environment, cooperation is key. So that's what we did. We were interviewing, we were collaborating, not only among tire manufacturers, but also with retraders and the end-of-life company, because the target for us was really to try to answer the call together. So I'm pretty happy to tell you that we are working on a new service and solution to cope with the goal. The principles are the following. So the tire manufacturers are still continuing providing data access for the brand new tires. But what we are looking forward is that retraders and end-of-life tire companies may have an active role as well. So they receive the tire and they start making their operation, let's say in a black box environment as far as GDSO is concerned. But then they have to declare what they did. The tire was repaired, the tire was retraded, the tire was scrapped, the tire was recycled. Because then, in that way, we can really enrich the data set that we are using. And for example, the first retreader may feed the second retreader as well. And the second retreader may get benefit of that information, as well as end-of-life tire companies. That is mostly the same. We are expecting also end-of-life tire companies to provide their declaration upon their operation on that specific tire. The last but not the least, GDSO, again, and once and for all, to still act as a trust and security party so that we can really simplify, standardize the sharing of data along the different stakeholders that may get benefit of the digitalization for tires. So this service is not in place yet. We are in a kind of incubator stage. We are starting working on that. And I will be back to Michael and many others to work together. But that's, let's say, the big news I wanted to share with you today. Because as I said, the tire identification is a key point, but it's just a starting point. We need to collaborate. And for the benefit of retreaders, we need also retreaders to play an active role in this system so that you can get benefit in getting data, but also everyone can get benefit in updating the information about tires, talking about the operation that you put in place. And that's it. Fast and furious, I guess.
Thanks, Riccardo. Yeah, any questions, please? Yes, Michael.
Thanks, Riccardo. I mean, we've been in contract very often, and I hope we will be in the future. But one of the major questions that arises from all the stakeholders in the market, of course, is how fast will this be technology worldwide being present in a certain percentage? So it's worth into a logistical part, into the retreading parts to invest in that, into the reading structure, into the data structure behind it. And what is your approach where this, I would call it external data, which are not hosted by the new tire manufacturer directly, how can it be managed that these tire on a security safety level can be merged to the initial tires, which are data which is provided by the new tire manufacturer? Thanks.
Thank you, Michael, for the two questions, because it's not just one. So to answer the first question, tire industry is not so famous to be very fast, especially for technology implementation. But we have the commitment from the key and biggest tire manufacturer to implement this kind of electronic identification. The scale-up requires still some time, but I'm pretty confident that we may see something pretty soon, beside what I would say any tire manufacturer may have as a plan. Because, for example, the European Digital Product Passport within the eco-design for sustainable product regulation may start requiring, as a legal requirement, an electronic identifier for tires starting from 2028, 2030, maybe something like that. So let's say that could be the time span. Is not that far away. And that's the first question. The second question is, without spoiling the solution, as I said, we are in a kind of an incubator stage. The target could be to link every kind of event to the original identity of the tire, so to allow somehow the retreaders and key stakeholders to push the information back to the tire manufacturer, so that the GDSO, again, organization may act as a trusted party, saying, okay, Michael is a trusted party. They can push the information back to the tire company, and that's the database that will be enriched and available over time. Otherwise, the risk is that we may go for a kind of fragmented approach with a database from one side, another one from another one. But that's what we are building, and we will be back to you and BIPAVER again for let's say, collaboration and solving any kind of open point.
Okay, of course we will need to discuss data property.
Yep.
Afterwards. I'm not sure that every retreader wants to have his data being supplied to the new tire manufacturer, but that's a question we're going to solve in the future. Thanks a lot,
Sure.
Riccardo.
Thank you.
Anybody else? No? Okay, that's fine then. Thank you very much, Riccardo. That's very helpful. Thank you very much. Cheers. Well, we're well ahead of schedule at the moment. We're now moving on to our final presentation. We have two presenters here who will both come to the stage at certain points during the presentation. We have John Powath from IBP and Brian O'Connell, who is the Chief Commercialisation Officer for Silpara Technologies. Now, this is also a presentation which will be of interest to both to the recycling sector and to the retreading sector. The title is Affordable Sustainability, and it's about the latest developments in reducing operating costs as part of a sustainability program. So I believe Brian is going to start, right? Yeah, okay.
Good afternoon, everyone. Thank you for your attention, and thank you for your time today. Time is our most precious asset, and I appreciate that the greatest. It's always fantastic to be the last one up in the last presentation before a party. So hopefully you'll find the presentation worth your while. So as David said, my name is Brian O'Connell. I am from Silpara Technologies. And we're a startup company, not unlike a number of the companies that have already been up here. We are pre-seed stage, and what we're going to talk about today is how to create, or really come to grips with how to make sustainability affordable, because we have some lessons learned. And to preface the discussion, I just want to be clear that I'm not an economist. I am not a sustainability expert. What I am is I'm a business leader who really faces a lot of the same challenges that those of us in the rest of us in the room face, which is how do we get the global economy to pay for our efforts in sustainability. It's one of the things that we've become very clear to us as we've gone on our journey, is that sustainability does come at a cost. And that cost can be, or the price tag can be a lot larger than what we're willing to pay. And so what we did was we went back and we kind of took a look at, I tried to be as global as possible, so I use an example from the United Nations. The United Nations has their Sustainable Development Goals, and they publish their Sustainable Development Goals every year. In 2023, in September of this year, they came up with a cost to achieve their 17 stated sustainability goals was roughly $195 trillion. That's trillion with a T. That's an enormous number. It's more than the gross domestic product of the 5 largest economies in this world looking out 15 years. It's an immense number. And that number has gone up by $20 trillion in the last 2 years, or in the last year over year. And the reason for that is, number one, it's the sustainability goals are being underfunded. People are not paying for those goals. Number two, the shortened timing. People are saying that we need to get to those sustainability goals in a shorter time frame. Number three is inflation. Obviously, inflation has been something that has affected all of us, so the cost of every good is going up. And then you have rising net zero cost. There are costs to everything. The technologies that we've witnessed here today cost money. The technologies that we need to implement to achieve net sustainability, those costs have gone up. And then the final item that I put on here is carbon offset. There are a lot of very large organizations who may or may not pay for their sustainability in real innovation or in real technological development. What they will do is they will pay for a carbon offset, and they will allow themselves to claim that they are at a sustainable level. Looking at this and where we fit in as an industry as well as individual companies, we know that roughly 40% of the costs, that $195 trillion, they estimate that 40% of those costs must be taken care of by innovation and technology. So technology has to step up and mitigate up to 40% of that cost. How is that going to happen without it being paid for? If we look at sustainability, people ask, well, what is sustainability? Sustainability can mean a lot of things. Sustainability can mean you're going to pick up the litter that one of your colleagues may have left on the floor. Sustainability could mean that you're going to take a bus instead of drive, take a train instead of fly. Sustainability means a lot of different things. What we consider to be, or what I've considered to be the circle of sustainability is really our ability to maintain a process continuously over time. So you can't put small stopgap measures in place in order to reach sustainability. You have to be consistent. What does it mean as far as we're concerned? I like to use three distinct areas. You've got your people, you've got your planet, and then you've got your profit. None of us are in here to lose money today. We're all in here because we need to eat and we need to sustain our families, we need to sustain our lifestyle. So in order for the people, i.e. the human effects of the economic system to remain sustainable, we've got to make sure, and in order for the planet, and for us to support the life systems on the planet, we've got to make a profit. A profit has to be generated. We cannot forget that. People have to be willing to pay for this. So what is the reality? What is the cold, hard reality? The cold, hard reality is there are many examples of failed ideas where people, either due to lack of affordability or lack of ability to pay, that the concept either seems out of reach or is subject to failure. We've seen a number of organizations here today who are at startup level. They're looking to gain funding. I congratulate the funding that you've received. It's a very hard thing to raise 15 million euros. You know that. I've been working on it for 5 years now. So it's an extremely hard thing to gain someone's trust that you're going to do what you say you're going to do and reach the goals that you say you're going to go out and achieve. So that concept and the reality that we have is we have to make our technologies affordable. We have to make our technologies available. So what is our focus? Our focus at Silpara is to basically introduce a sustainable technology into a 135-year-old industry. That also has to increase performance at a cost that the suppliers, the users, and the producers and the end users will accept. It's an extremely difficult thing to do. And as all of you who have been in this industry a lot longer than I have, you know, I heard someone say earlier, the industry at the OE level acts pretty slow. There's no doubt about it that the industry is not a fast industry to adopt. And so our focus and our challenge as an organization, as we've discovered, is to change a 135-year entrenched industry, which is extremely difficult. So when it comes to affordable sustainability and pricing, a lot of the conversations that I've had with folks this week, as well as in the 5 or 6 years that we've been doing what we do, is how much is it going to cost? What is your price? I understand and I appreciate downstream what the savings are going to be. I understand and appreciate upstream what your commodity costs are. What's it going to cost me today? And my question to them is, what are you willing to pay for sustainability? Most people reach into their pocket and say, well, the spare change that I might have. They're not going to pay 50% more. They're not going to pay 30% more. They're not going to pay, even in some industries, 1% more. A lot of the industries that we see today going to single-use tires. Single-use tires may or may not be the way that the companies are able to afford putting tires on their vehicles. Single-use tires are going to go after the retread industry in a big way. I know in the North American space, that's the biggest problem that they have in the retread industry today from a product implementation perspective is single-use. So how do we get around the affordability question with, you know, a circular economy and sustaining a circular economy when you have other factors that are trying to put you out of business? Scale. Some folks talked about scale today. From source to channel. How do we make sure that those conservative first and second adopters are going to take you in and say, yes, you're a good sustainable option for us, and you're affordable for us. We need to have that in the back of our minds. Raw materials, obviously the recycling cost of the infrastructure, the fact that there is a lack of a circular economy today. We've been talking about circular economies. We've heard it this afternoon. That circular economy doesn't really exist. It's very, very disjointed, and it's disassembled. And so we have a very large challenge in the industry with that. There are certifications that need to go in place, extensive testing up front and on the back end as well. And as some of my counterparts have also said here this afternoon, lack of a specific regulation and getting a regulation passed. How many years? 7? 9? Okay. Sorry to bring up a painful point. But as we can see, lack of regulation. I know in some instances here, I feel like I'm preaching to the choir, but let's talk about reality. There is a reality. People have to be willing to pay. So the large players, they have a lot of internal momentum. They're not going to give you the time of day unless you're coming in and you're offering them 50% cost reduction and better performance. Let's face it. Everyone has a KPI that says, I'm going to save 10% in my cost this year. And then at the end of the day, the slow adoption rate, and we talked a little bit of that on the practice. So we have many trade-offs, and the trade-offs are numerous. I won't go through these individually, but you can see them in the presentation. In order to get from your price in the performance to get to the sustainability, how do you break those trade-offs? How do you go through and get true innovation that breaks those trade-offs? So what we're going to talk about briefly, I will turn it over to John here in just a little bit. We're going to talk about case study and tire performance. And what we're going to focus on is, there are 5 major sections in regards to where the tire industry is committed to going to a net neutrality and carbon reduction by 2050. Of this net reduction, the tires represent 15%. 15% of the global tire carbon neutrality is going to come from the fuel efficiency of the tires themselves, as well as from the reclamation of those same. The industrial operations are one part of it, the logistics, supplier compliance, but product energy efficiency with the non-tailpipe emissions, as well as through the rolling resistance. Those are the keys. So hopefully we all know the magic triangle. We use the magic quadrangle. The magic quadrangle for us is to expand that envelope from 1 to 1+. And to do that at a rate that is going to be just as affordable as the product that you have today, if not get some value for that product based on the fact that you have a better performance. So we know in our particular case, we're trying to mix silica with natural rubber. That's been the probably hardest technical barrier for truck and bus tires achieving next level abrasion and rolling resistance performance. I think that could be agreed upon. At least 98% of the folks that we've spoken to and gone to the industry for have told us that that is going to be their biggest issue. So what we're trying to do is get silica and natural rubber to play well together. And in order to do that, what we've done is we've created a drop-in process. Does not require any type of a reactor to do. It is mixed basically at the source of the natural rubber in the plantation, and requires much less water. John's going to talk about this, but it requires much less water to produce. As a matter of fact, folks may or may not know this, but in order to coagulate and dry natural rubber into sheets, each kilo requires 15 liters of water. Our process will take 15 liters of water out of the process. We'll save the water on the back end. And then as far as the product performance is concerned, we have been able to reach, in certain formulations, we're at parity with rolling resistance. Some formulations were a little bit higher in rolling resistance, up to maybe 20–25%. We're going after the abrasion resistance, which is going to increase the wear component, and our hot tear numbers are looking very, very good. And then as we focus on wet traction, we want to make sure we're at parity. We're not giving anything up to the customer. So this is the last slide I will talk to, and I will turn it over to John. But from an overall savings perspective, what we're expecting to get and get paid for, we're not going to get paid for it the traditional way. We're going to get paid for it through performance. Our solution provides a little bit of an innovation, or a lot of innovation, when it comes to the problem that we've gone out to focus on. And you can look at the numbers there. It's a gigantic opportunity for the industry to go after. Looking at it from front to back in the ecosystem has been our approach. John's going to talk a little bit about the savings that we're looking at and where we're going at from an environmental perspective. But hopefully, at the end of the day, what you've taken away here is that as an industry, we've got to innovate. We can't greenwash. We've got to go after real problems and solve them with real technology. I thank you for your time. I'll turn it over to John.
Good evening to all. I'm going to be very short and sweet, not more than 3 slides. So, everybody in the room is aware about tires. We know how to manage the process. We all talk about carbon footprint. But have we, at any point of time, stopped and said, what is more important? Is it carbon footprint or water footprint? So these are some numbers that you would know. The production of natural rubber, 14 million metric tons. I'll just correct what Brian said. In the entire process of making 1 kg of RSS or block rubber, we would be using conservatively 25 liters of water. That's the entire process. You have to wash the plates, put everything into place. So if we assume out of the 14 million metric tons, if 10 million goes for the tire industry in form of block or RSS, we would be consuming 250 billion liters of water. Now, that looks like, what is 250 billion liters of water? Just to give you an idea, a pictorial description, 1 billion liters of water is equal to a small lake. So every year, we throw 250 lakes out just in tire production. That means when we are creating the natural rubber. Now, what if you can save 250 billion liters of water? That is going to be a game changer. So the whole process, when the Silpara sheets are manufactured, there is no external water used. You take the water that's there in the latex and let that dry. Now that is what is going to be a game changer. Most of the time, companies come and say, we have these sustainable goals, nice writings on the wall, but zero action on ground. This is where you can actually put action on ground. So the question is, will the consumers, will the end users say, yes, I want a sustainable product? Now, the beauty about the product that Silpara has is it's not going to cost more. As Brian said, it's affordable sustainability. That means you will start saving money. And very simply, for every tire, retread that you use, you'll save about $1,000, over the life of the tire. And that is equal to actually buying a new tire. So besides just saving money, you can actually be sustainable on the carbon footprint side, and more importantly, on the water side.
Water. It's one of our most precious resources, but our water supplies are limited. 97.5% of the Earth's water is salty, and only 2.5% is fresh water. But over 2/3 of this fresh water is locked in the polar ice caps and glaciers. This leaves only 0.5% in our lakes, rivers and groundwater for agricultural, industrial and personal use. But due to pollution, the quality of this water is under threat. According to the World Health Organization, only 0.007% of the world's total water supply is safe for consumption, and this minuscule amount needs to be shared by the more than 7 billion people on the planet. And this water is not distributed evenly throughout the world. 1.2 billion people live in areas of water scarcity in places such as southwestern United States, India, Spain, North Africa, Australia, and northern China. At the same time, demand for water is. Over the last 100 years, global population has tripled and water consumption has increased sixfold. But our total water supply has remained unchanged. More people are now using a lot more of the same limited amount of water.
So I just wanted to give you an idea as to if we happen to use the low rolling resistant compound, what could we save? So I just took an obscure small country called Sri Lanka, and if we actually start using, and they have, a very small distance to travel, truck population of under 500,000, and if we just assume half of them would be eligible to put this in place, and at 4% saving, we are looking to save, about $50 million. Now, translate that into Europe. So these are things which can be, where you can actually measure. We have a gentleman talk about how we can do tire data measurement. This is very easy. You can actually measure the carbon footprint that you're going to save, the water footprint. It's going to be a game changer. I think the question I want to just leave with the audience at this point of time is, are we ready to so-called modify or recreate rolling resistance standard across the world? Because that will start reducing tailpipe emission. I mean, for instance, if I may just say, the EU is talking about microplastics in infield bans. That's very nice, but honestly, is that going to make a real impact? No. These are areas where they should be focusing on. Second is, from the rubber and tire industry. While we can say 2030, 2050, I can tell you by the time things move on, they will make it, 2100 and say that's when we're going to be sustainable. They'll start pushing that. Will they voluntarily adopt these standards? And will EU as such, take the lead to saying that, can we have specifications for tire standards that is linked to casing retreadability so that we actually move away from single-use tires and introduce a water tax in addition to a carbon tax and put regulations around that? Then you're going to have, more teeth behind the regulations. That's it. Thank you all for patient listening.
Thank you very much, John and Brian. Are there any questions, please, before we finish? Krzysztof.
Thank you guys for a very nice presentation. As you've heard before, I'm not a big fan of silica and in rubber. That's why I just wanted to ask how much silica you can put in natural rubber with your solution.
The solution that we have on the books today would be about a 4% level.
4%. Okay, we might survive then. Thank you.
Any other questions, please, before we finish? No, well, just before we do finish, just a couple of quick notes. The first thing to say is that we have been recording these sessions, and subject to the agreements of the participants, we will be able at some point to share a video of the of this seminar, and also potentially the actual presentations themselves. We'll distribute those within the coming days and weeks. Second is to thank everybody for coming today, and especially those of you who stayed until the end. Now we are going to have a break now. We finished a little bit early, so please go and have a drink and something to eat. Enjoy yourselves, but please don't go away, because in 5:45 we are going to have the awards ceremony for the Recircle Awards, which is our awards programme to celebrate excellence in the tyre retreading and recycling industries, especially within the circular economy. And I know that there are a number of nominees present today, so please come along and support them. We're giving out 20 awards this evening, which means there's been approximately 80 companies and individuals nominated for these awards, and they're all very deserving of their nominations, so please come along and support them. So thanks very much for now, and enjoy your break. Thank you.